Today we're going to learn, we're going to kind of give you like an overview, I guess, of these different types of graphs we're going to do. Now, we just talked about how to do like a y equals mx plus b slope-intercept line. So what we're going to do right now is we're going to do another one of those, but it's a little bit more specific than just a normal just y equals mx plus b. It's pretty basic, but they call it the identity function. Do you see that on that little paper I gave you? I think the first one is called identity. Do you see that? Okay. All right, it's called the identity function. Now that little paper that I gave you, I'm only going to concentrate on the first two rows. Do you see that? Okay, so the stuff down the bottom, 4, 4, and 5, 2, and 5, 3, do you see that? We're not doing those right now. So we're just on 3, 5, on section 3, 5. So those are the only ones we're doing, section 3, 5. In fact, you see at the end of the second row, it says 4.5. We won't even do that one today. So we're just going to do 4, 5, 6, 7. I don't even know if I'll do that seventh one. Do you see that greatest integer function? I don't even think I'm going to do that one for you guys. But we'll do up to absolute value, I hope. All right, so the first one is identity. Identity is really simple. It's basically just this. It's really not much different than what we've done before. It's just y equals x. So if I was to graph y equals x, what do we have here? Well, what's the y-intercept? If I just said graph y equals x, what's the y-intercept right here? You don't see it, but it's there. What is it? Come on, somebody talk to me like you're live today, please. What's the y-intercept? The y-intercept is a straight line. Come on, think what you're saying. What the y-intercept is this. What is that on this function right here? Here's the graph. Say it, Tiffany.
0.
It's 0. Okay, it's 0, right? There's no y-intercept there, is there? So the y-intercept is 0. So if we were to graph this thing, we would put the y-intercept right here at 0. Everybody see that? What's the slope of this? What's the slope of this line I have in the box right there? It's y equals mx. What's being multiplied by the x here? A 1. That's right. So what's the slope of that line? It's a 1, isn't it? So if we come here, what do? We rise 1, we run 1, and now, or we could rise 2, then run what? 2, or rise 3, run 3. You follow me? So if I'm over here at 7, where am I going to be on my y-axis? At 7, because y equals x. So no matter where you go on the x-axis, you're going to go to the same spot on the y-axis. If I go to negative 3 on the x-axis, where's that going to be? On the y-axis, it's going to be at negative 3. Everybody see that? So whatever the x is, that's what the y is going to be. If you wanted to, remember doing this stuff? This little xy chart. Some people call it a T chart, whatever. I just call it an xy chart. Remember doing that in Algebra 1? Plug in numbers for x and find out what your y is going to be? Yeah, so plug in some things. Plug in like a negative 2 in for x, and a 0 in for x, and maybe like a 3 in for x. So what's the y going to be? If your equation is y equals x, here's your equation right there. If your equation is y equals x, if I say x is negative 2, what's the y going to be? It's going to be negative 2. If the x is equal to 0, what's the y going to be? It's going to be 0. Everybody with me? And then 3, 3. I'm doing this. This is really basic. It's really pretty simple. But I'm doing this because it actually leads up to the other stuff that we're going to do. Okay, I promise you it does. So if I go to negative 2, right, then I go down to negative 2, and boom, it's right there on my line, isn't it? Now, they don't ask you this, but what kind of angle do you think this makes with the x-axis? 45 degrees, exactly. If you go over the same amount, watch. So if I took a point here and I drop this straight down, so remember, I go over this. Let's say we went over 5. We went over 5. What do we have to go up? We got to go up 5. Do you remember this from geometry? It's an isosceles triangle, and it's a right triangle. So that means these two angles right here are equal to each other. Anybody remember this from geometry? Okay, 45, 45, 90 triangle. Yes? All right. And I can actually find the length if I wanted to, but we're not going to get into that. But you're absolutely right. It's 45 degrees. All right? Okay, enough of that. Let's do another type. That was the easy type. Let me flip the page here. What are we doing now? A squaring function. Okay. So a squaring function would be something like this. This is a real basic version of this. I believe in another, let's see, do they Yeah, I probably won't mix it up until the next time we teach this. But I will change things up a little bit on this. Let me see. Yeah, I want to take this kind of slow. I don't want to just overwhelm you with this stuff all at once, but I do want to show you this. So let's just graph this. Now, if I ask you to graph this thing just from scratch, and you're like, I have no idea what that thing's supposed to look like, what's a good way to figure out what a graph looks like? If you have no idea how to graph it, I would always do this. And you think, well, that's kind of baby stuff. I learned that in pre-algebra. I learned that in Algebra 1, how to graph things with this little XY chart. You know, here I am in college algebra, ready to graduate high school. I shouldn't have to go back to this chart, which is an Algebra 1 kind of a thing. No, not at all. This is really, really helpful. It's even very, very helpful on real complicated functions or real complicated equations. So we use this all the time in college. If I was to graph something and I didn't really know what the thing looked like, I would always go back to this thing. All right, so it's not elementary. It's not, a little baby way of doing things. It's not at all. It's a very, very good way of graphing things if you're not really sure what the graph is supposed to look like. All right, so let's put some numbers in here. Let's just put a few. Let's start at -2. We'll go -1, we'll go 0, we'll go 1, we'll go 2. All right? Just to give us a variety of numbers, just to really get us a good idea what this graph is supposed to look like. Now, before I even draw the x and y axis, let's put some numbers in for y. Now, remember, this is my equation right here. I just picked values for y. All right? You could have picked anything. Okay? You didn't have to pick these numbers. But for this equation, these are good numbers because they kind of are centered at 0. It's just a good idea to pick numbers that are closer to 0. It just gives you a better idea of what it looks like. You don't have to draw your graph super huge and big. It's just a good variety of numbers to start off with. All right, so let's start in the middle right here. Let's do 0. Okay, that's probably one of the easier ones. So if I put a 0 in for x, what's y going to be? Y equals 0 squared. What's 0 squared? It's 0. Okay, so if I put a 0 in for x, y is going to equal 0. See what I'm doing? Just plugging numbers in for x. That's all I'm doing. And finding out what my answer is going to be, what y is going to be. Let's put in a 1, a positive 1. So 1 squared is 1. So far, it looks like whatever you put in, you get the same exact number, don't you? But is that going to hold true throughout the whole thing? No, it's not. Because watch, when I put in a 2, I don't get a 2. What do I get? 2 squared, which is 4. Everybody see that? And if you want, let's put in a 3 just to extend it a little bit. What if I put a 3 in for this? What am I going to get for y? I'm going to get a 9. Everybody see that? Let's go the other way. Let's go negative. I just did the positives because that was a little easier to deal with. Now you get the idea of what we're doing. Now let's put some negative numbers in here. So you put in a -1 in for this. Now you got to be careful. You're putting a -1 in for x, but what are you doing to it? You're not just doing this, are you? Everybody see that? You're not just squaring it like that. What are you squaring? You're squaring the whole entire -1. It makes a big difference. Everybody see that? So you're squaring the entire -1. What does this become? What's -1? This whole -1 squared. It's +1, isn't it? So if I put in a -1 in for here, look what I get. I get a +1. If I put in a -2, watch. If I put a -2 in for x, I have to square the entire -2. Which negative times negative is positive. 2 squared is what? 4. Of course, if you wanted to, you could put a -3. What would I get if I stuck a -3 in for this? I'd get a +9. Will I ever get a negative out of this? No, because you square anything. You square negative, square 0, square positive, you're always going to get a positive. Right? So now we're ready to graph this thing. So let's, I'll tell you what, let's do this. Let's scooch this down here, just so I can put my graph right next to it. Again, my graph is y equals x squared. So let's graph this thing. All right, let's put some. Now look at my x. We'll take it out to 3. 1, 2, 3, and then 1, 2, 3. And you're going to have to go up a little bit higher. I don't even know if I want to go up to 9. We'll just go up to 4. 1, 2, 3, 4. Do I even have to put any negatives on this? No, because my y will never come out negative, will it? If you want to put the negatives in here, you can, but you're not going to use them, so I'm not even going to bother putting them in there. Alright, so let's just label this -1, 2, -3, 1, 2, 3, 4. All right. Now we're ready to put some points in here. So let's forget the 3 right here. Let's just do the 2. Go from -2 up to +2. -2, 4. So I go to -2 and I go up to 4. That would be right there. Put a dot. -1, 1 would be right here. Now, if you remember, when you first did this in Algebra 1, your teacher usually told you all you got to do is put 2 in there, right? Because 2 points make a line. So we're just gonna pick any 2 and just do a straight line through this? No, we're not. That's why I picked more than just 2, because this doesn't become just a straight line. This is not y equals mx plus b, is it? All right, this is not linear. It's not just a regular straight line. You got a squared in there. Okay, so your graph looks a lot different when you have a squared. So you can't just pick 2 points and connect them. You got to put some more in just to kind of get a pattern, see what's going on. Put a 0 in there. 0, 0. Put a 1 in there. 1, 1. Put a 2, 2, 4. Looks like that. You can put other numbers in there. Watch, if I put a 3, look what we're going to do. We're going to go way up here to 9. Everybody see that? If I put a -3, you're going to go way up here to +9. So what does this look like? Is this just a bunch of straight lines? Can I put a straight line that connects from here to here? No, because this is kind of off a little bit. So it's going to be a curve. And this is the hardest part, especially on this program. Yeah, that's where I always mess up, right at the end here. Try to make it a little bit curvier. Alright. I wish I had a function on here where I could make a nice, perfect curve, but I guess I could. I guess I could put like an ellipse thing on here and like cut off half of it, but I'm not going to. That's good enough right there. That's what your graph looks like. Okay, that is a, what do they call it? A squaring function is what they call it. Alright? Just write that down. A squaring function. So when you square something, your graph will basically look like this. This is your most basic graph. So this is a quadratic, isn't it? Well, I shouldn't say that. Let's not even say that. Let's just say it's a squaring function. So whatever x is or whatever it's in there, if I square it, your graph's going to have a basic look like this. We're not going to talk about this today. We'll talk about this maybe when we come back from break. You could take this graph and shift it. Watch. Did I thought I made that one big old thing. Maybe did I stop in there? Let's do that. Okay. Oops. Watch, we're going to do stuff later where you actually take this graph and you shift it this way. Okay, or you shift it up like that. Or, watch this, you make it wider. Everybody see that? And there's things that you're going to do to this to make it wider. And there are times where you're going to make it skinnier and make it look like that. Right? There's a lot of different things that you can do with this. Let's put it back to where it was. There's a lot of things you can do with this, but this is your basic, ordinary, everyday squaring function. Okay, I didn't change it around. It's centered right there. The vertex of this graph is right there at 0. By the way, we call this a parabola. You ever hear of that? Yeah, you probably did this in Algebra 2. All right, it's called a parabola. All right, let's do another one. Let's do one. We did a squaring. What do you think the next one up would be? How about what? Cubing. Nobody talking to me today? So let's do a cubing function. So what's that going to look like? Y equals x cubed. So we want to figure out what that graph looks like. Now, before I even put the x and y axis, before I even start thinking about graphing it, let's put some numbers into that little xy chart thing. All right, and see what we get. This is very, very important. I'm going to do this every time, okay, with this little chart. It's really, really important. Let's put a couple negatives in there. We'll go -2, -1, 0, 1, 2. Because if I put a 3 in there, look, 3 cubed is what, 27. Do I really want to go to 27 on my graph? Not really. So I'll make it, I'll make it fairly easy to fit it onto a graph.
Please send Alex Davis to the office for just a minute.
Yes.
Thank you.
I don't understand why they call people to the office just for a minute. You should wait till after class and say, come after class. I don't get that. Because sometimes people go there and they say, oh, you got this mail or you got this message, that could wait. I don't know. Maybe that's just me. All right, so here we go. Or it could be something very important. So I could be saying that, and maybe he had to know right now. So I shouldn't say anything, I guess. All right, I'll shut up. Let's do this. We're going to cube this thing. -2 cubed. Now watch. It's -2, and it's being cubed. Make sure you know how to cube this. If you cube a negative, what do you get? A negative. And then 2 cubed is 8. So this actually does come out negative, doesn't it? Unlike the squaring functions. If you squared or took it to the 4th or any even power, you'll never get a negative here. All right? But when you have odd, you could get negatives. All right? So let's do the -1. If I take -1 and I cube that, then what do you get? You get -1. Everybody see that? Because 1 cubed is 1. And if you cube a negative, right, negative times negative times negative, it's going to be negative. All right, put a 0 in there. 0 cubed is 0. Put a 1 in there. 1 cubed. 1 times 1 times 1 is just +1. Put a 2 in there. 2 cubed is 8. You could put more numbers in there. You could put numbers that are in between 0 and -1 or 0 and 1. You could put a half in there if you wanted to. All right, you don't really have to do that, but if you wanted to make your graph a little bit more precise, you could put in between numbers if you wanted. All right, let's do this. Let's put some numbers in here. Now again, my x is only going to go to -2 and +2. My y is going to go up a little bit higher. So let's make this line a little bit longer for the y-axis, because I got to go up to 8, don't I? So I probably won't stretch them out as much. 1, 2, 3, 4, 5, 6, 7, 8. Now I will go down because I do have negatives on my y this time, unlike before. All right, so let's put some numbers in. Let's start in the middle first. Let's start right there. It's just a good place to start. 0, 0. So we're going to put a point right at 0, 0. 1, 1. Put a point right there. Now if you go to 2, now look, if those are the only 2 you put, you don't make a straight line, do you? You got to put a lot more in there to get an idea of the curve of your line. So I'm going to put in a 2. Put it in 2, and you go way up to 8. Look at that. See that? I can't just connect the first dot and the last dot, can I? Because it's going to leave something out. So it's going to be a curve. So it's going to look like this. Watch. This part of it is going to curve like that and like that. It's going to keep on going. It's supposed to be smooth. That's not the smoothest curve ever, but you get the idea. Try to make it as smooth as you can. All right? So it's going to be a nice smooth curve like that. But is that it? Are you done? No, because you got negatives as well. And they don't go up like the other one did. This one goes down. So watch. If I go to -1, I go down to -1. So right here. If I go to -2, I go down to -8. So it's basically going to look like this, isn't it? Except you kind of flipped it around this axis and then flipped it around this axis. And your graph should look something. Oops, almost. Yeah. Here we go. And I'll fudge this just a little bit. Put the point right there. All right, and that's what it looks like. This one on the left looks a little smoother than the one on the right, but it's one continuous function, isn't it? Now, to draw this, I actually did pick my pen up, but did I really have to, though? No, I could have started here, gone all the way through like this, okay, without ever picking the pen up. So it is a continuous function. There's no holes in it, and that's what a cubing function looks like. So whenever you see something that's cubed, it's basically going to look like this. Now, again, we could change this around quite a bit, but that's your basic everyday cube function. Looks pretty weird, but it wasn't that hard to figure out, was it? Using that x and y axis, you plug numbers in, and you get a general idea of what that function is going to look like. All right? Well, we did a squaring function before this. Let's go the opposite direction. What's the inverse of squaring something? Square root it. So let's do a square root function, and let's see what that looks like. Square root function. All right? So what we're going to do is we're going to graph y equals the square root of x. So where are you going to start? XY chart, right? Whatever you want to call it. I think it's pretty important to use this. Now watch. Earlier we put -2, -1, 0, 1, 2. Can you put in a -2 in for this? No, you can't, because you can't take the square root of negative number. So my x's, none of my x's are going to be negatives, are they? Okay, I can't put negatives in here because I can't take the square root of a negative number. It doesn't come out to a real number. It comes out to an imaginary number, and I can't graph imaginary numbers. Okay, so I got to put in, what's the smallest number that I could possibly put in for x?
0.
It's 0. That's right. So let's put a 0 in there, and we'll put a 1 in there. Now you could put a 2 in there if you wanted to, but remember, we're taking the square root of this. And it's kind of nice for our answers to come out to be nice whole numbers. It's just a little easier to graph it. Now you could put a 2 in there and take the square root, stick it in a calculator, and figure out what it is. But what's the next number after 1 that you can take the square root of that comes out? 4. So let's put a 4 in there. And let's do one more. What's the next one that you can take the square root of? A 9. Let's put a 9 in there. Okay? So now we're ready to do our little x and y axis thing here. Put it right there like this. Oh, let's put the numbers in first. We didn't figure this out, did we, before we graph it? Let's put the 0 in there. What's the square root of 0? It's 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. All right, so this is what we're going to graph right here. And if you look, x goes all the way to 9, doesn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9. And then my y just goes up to 3. I'll stretch that out a little bit. Okay. Now we're ready to plot the points, figure out what our graph's going to look like. So where do we start? 0, 0. So let's put a point right there at 0, 0. Then you have 1, 1, which would be right here. Then you have, watch, 4, 2. 1, 2, 3, 4, and then up 2. Looks like this. And then you got 9, 3. 9 is way out here. 3 goes up here like this. Look at that crazy graph. So what's that going to look like? It starts here. It's going to curve. If I could draw this. Come on, come on. I almost made it. You think it's hard drawing it on your own paper with pencil. It's even harder drawing it on this thing. But anyway, make the dots real big so it looks like it actually hits. All right. So there's a nice little curve right there. Notice it doesn't go below the x-axis. Why? Because the range, if you look at this, remember we did domain and range? That kind of stuff helps you with this. Because the range is going to be everything greater than 0, right? Because you can't have any negatives for your range. And my x's can't be negative as well, because I can't put in a negative number. I can't take the square root of a negative number. We good? So when I take the square root of these positive numbers, I'm always going to get a positive number. So look, everything's above the x-axis and everything is to the right of the y-axis. And that's what your graph looks like. That's your basic, ordinary, everyday square root function. So if you see something that's a square root, looks like this. Brian, you getting all this? You were doing pretty good until the last couple minutes, and you started losing me here. All right, so that's that. What do you think? This x and y chart's pretty helpful, isn't it? To figure out how to graph these things. Yeah. You're probably thinking, I'll never have to graph this kind of stuff in my whole entire life, and you might be right. Okay, I'm not saying you're wrong on that, but that doesn't mean it's not a good thing to learn now. There are people that do need to know how to graph things. I mean, a lot of, especially in the sciences. Okay, in the sciences, there's a lot of times where they take this data, they'll do experiments, and they'll get data and points, and they have to graph them and all that kind of stuff. Now, today's world, they're probably not sitting there by hand graphing these things. Okay, they put the data points into a computer, they compile it, they give you a graph of what stuff looks like. But it's nice to be able to see it. If you saw a graph that looks like that, you're like, oh yeah, that's a square root right there. Just looking at it, you know that's a square root. Okay, just looking at this thing, okay, it goes down to the left, goes up to the right. Just looking at it, without even seeing any numbers, you know it's a cube function, all right? And just looking at this right there, you know it's a square function. And there's people out there, there are people out there, I'm not saying you're going to be one of them, but you never know. You just never know. If anything, you'll have to do this in college. So we'll put that as a reason why we need to learn this stuff. All right, let's do another one. We did a square root. What do you think we're going to do now? We did squaring, then cubing. We did square root. What do you think we're going to do now? We're going to cube root, right? So let's do a cube root function. All right, it's the same thing. well, it's not the same thing. I shouldn't say that. We're going to start off doing it the same way. We're going to do that little XY chart thing. But we're taking the cube root of it. So what does that look like? It looks like this. It's the cube root of x. This has its own little look to it. Now, can we put negatives in for x this time? We couldn't on a square root. Can we put negatives in a cube root? Yeah, we can take the cube root of a negative number, sure. Just like we can cube a negative number and get a negative answer, right? So we can definitely cube a negative number. So let's start here. I'll just give you a good starting point. Negative 8 is a good number because I can cube an 8, right? So I can cube a negative 8. What's the next number I can cube down? Probably not until you get to 1, right? Because 7, 6, 5, 4, 3, 2, I can't take the cube root of any of those numbers and get a nice whole number until I get to 1. Right? I can take the cube root of 0, and now I'm going to go positive 1, and I'll go positive 8. Now you could have gone up. The next one up would have been, what, 27, but I don't want to put 27 on my graph. So we'll just go to 8. That's good enough. Let's put some numbers in here. Put negative 8 in there. What's the cube root of negative 8? It's negative 2. The cube root of negative 1 is negative 1. The cube root of 0 is 0. The cube root of 1 is 1. The cube root of 8 is positive 2. And this is what we're going to graph. Now you're getting the idea of what we're doing now, right? Hopefully after all of these. So how am I going to number this? Well, my x goes from negative 8 to positive 8. So on the x-axis, I'll go to 8. 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. And this only goes from negative 2 to positive 2. Positive 2, negative 2. Now we're ready to graph this thing. Now we do have negatives here, don't we? Because it's a cube root. Now if it was a fourth root or a square root or an even root, you wouldn't have negatives because you can't take an even root of a negative number. All right. So let's do this. Negative 8. I'll tell you what. Let's start in the middle. 0, 0. All right. So right there. 1, 1. Right there. And then 8, 2. Right there. Kind of looks like that square root function, doesn't it? All right. So if I connected them, it would connect just like that. But this is not the only thing. We also have negatives. So let's go negative 1, and then negative 8, negative 2, be right here. Okay, and now we're ready to graph this thing. I'm going to kind of graph it in two parts, even though it's one continuous graph. I'm going to start here. Now, when they're real skinny like this, it's hard to show the curve. Come on. Almost made it. Tell you what, let's put this dot up here like that. Cheated just a little bit. Okay, and then let's see. Going left is even more difficult. So, ooh, that's pretty close. I made that worse, didn't I? That's all right. We'll just do like that. There's your function right there. Kind of looks like a square root function with another part going in the other direction, doesn't it? Or it kind of looks like a cube function just kind of turned on its side, doesn't it? Yeah, a little bit like that. All right, but that's a cube root function. So if you see a function like that, one part goes this way, one part goes this way, that means it's a cube root function. We're almost done. We've got one more to do. Just again, today is just an introduction to these types of graphs. We're going to do some stuff with this a little bit later, but today we're just introducing them so you just have a general idea of what it looks like. Okay, now what we're going to do, and we've talked about this stuff before, but I don't think we've ever graphed these before. It's the absolute value function. All right, you all know what absolute value is. We've dealt with that before. So let's write the graph down, or the equation down. Y equals the absolute value of x. So we're going to graph this thing right here. So where have we started? This whole squiggly. What did we do all day today? Doing this little XY chart and throw some numbers in. Can we put negative numbers in for x? Yeah, you can take the absolute value of a negative number, sure. So let's go negative 3, negative 2, negative 1, 0, 1, 2, 3. I did 3 because you don't have to go that far. If I put a negative 3 in for the absolute value, now remember, we're just taking the absolute value of it. It turns it into a what? Positive 3. Put in negative 2, it's a positive 2. Positive 1, 0, 1, 2, 3. And now we're ready to graph it. Probably should have done this one first. It's a little bit easier, I think. Oh, you know what I should have done? Let's put the 1, 2, 3, 1, 2, 3, and then down here. Alright. And let's go to a different color. Go to red, stay with the same color situation. Let's plot the points. Watch. It's kind of like that that first graph that we did today. That identity function, right? Except we're going in the negative direction and the positive direction. So watch, negative 3, 3. So negative 3, and then it goes to positive 3. Notice all these numbers over here on the y. None of them are negative, are they? Why not? Because of my function, because I'm taking the absolute value of it, right? So absolute value means I'm not going to get any negative numbers. So I'm not going to get anything down below this x-axis, down below 0 on the y-axis. So negative 2, 2, be about right there, negative 1, 1, and then 0, 0. Now these may not line up perfectly because I just kind of sketched my graph real quick. Just plot all the points there. Now look at this. Is this a curve though? It's not. It's just a nice straight line. It's supposed to be a straight line anyway. Goes here like this. That's pretty close. And that right there is your absolute value function. So your absolute value function looks like a V, doesn't it? But remember what I said we were going to do after we do all this. We're going to take this function and I'm going to show you how to move it around. What happens in your equation if it moves up here and it's doesn't have an origin at 0? There's going to be something we can do to move it over like that. Your function's going to look a little different than this. We're going to introduce some numbers. You could do this to it. You could take this function and squeeze it in like that. That changes things around, and there's stuff that you can do to this number to squeeze it in. Okay, there are things you can do to make it even wider than it originally was, and that's the kind of stuff we're going to do a little bit later. But today, I believe, let me just make sure, look at your graph here. Oops, you know what? Not even going to give you homework because the homework is stretching it and doing all that moving around stuff. We haven't talked about this. So this is just an introduction. Maybe we'll hit that tomorrow. We do have class tomorrow, so maybe we'll hit some of that stuff tomorrow.
If I could please